Welcome to Lecture 19. We are looking at 3.1 Quadratic Functions and Applications. So please note, for 3.1, we do not cover the objectives 1, 2, or 5 in Math 103. So we're just going to cover the following objectives. But first, let's take a look at the definition of what we're looking at. So we're looking at quadratic functions and applications. So by definition, a function defined by, once again, that function notation, and we are given that normal quadratic we're used to working with. Remember, whenever you see x and the highest power you see is a 2, that's a quadratic. So that is what we're working with here. And where a is not equal to 0. Real quick, how come we have to have that a is not equal to 0? Well, if you think about it, if a was equal to 0, the x squared term would be gone, and we'd have a linear equation. So we don't want a to be 0, or else we'd be with linear equations and that. That's not what we're looking at. So by definition, a function defined by f of x equals ax squared plus bx plus c, where a is not equal to 0, is called the quadratic function. Okay, so a few things to note. If the a value, so that value right there, is greater than 0, then what we're going to have is our parabola opens upward. Now, you might say, what is a parabola? Well, when you graph a quadratic function, you'll end up with a graph that looks something like this. A parabola. It either opens downwards or it opens upward. So when we have a greater than 0, we have a parabola opening upward. And for all parabolas, there's something right here, right in the middle, that is called its vertex. Every parabola has a vertex. Special thing about that vertex, for a parabola that is opening upwards, this point here is the smallest possible y value. The y values can't go any lower, so this is called a minimum. You'll notice in word problems, occasionally, the word minimum or maximum will appear. If you hear those words, more than likely you're working with a quadratic function and you're looking at the vertex. Okay, keep that in mind for word problems. Minimum or max, think of the vertex. Okay, so that's what we know here, is that if we have a quadratic equation with a greater than 0, opening upwards, and f of x has a minimum. Then, if we have a is less than 0, it's going to be the exact opposite. For a less than 0, opening downwards. So this is opens up, this is opens down. Okay, so then f of x has a, right here at the vertex, we have a maximum. Highest possible y value. Think of the top of a mountain peak. Versus for opening upwards, we would have, oops, let me go ahead and erase this actually. If we had a parabola opening upwards, we'd have a valley and there would be a lowest point. So we're looking right now at a parabola opening downwards, which has a maximum point right there at the vertex. Once again, maximum and minimum. Talking about the vertex. Okay, so one other really important thing that we go over for parabolas is something called the Axis of Symmetry. This is the line x equals h. Not super important to know that right there in this class, just knowing the axis of symmetry is important and the concept behind it. And this is the line. In fact, not any kind of line, this is a vertical line that passes through the vertex. Right here. Okay, so it passes through the vertex. And remember, our parabola might not always be smack in the middle of our graph. It's possible that we might have a parabola that could be somewhere off to the side. Like so, maybe we have a parabola opening upwards like this. And then our axis of symmetry would be wherever the vertex is, right here. What's special about the axis of symmetry? Well, basically it's saying it's symmetric. If I have a point right here on this side of the parabola that is 2 spaces away. I know for certain, because of the axis of symmetry, that a point exists on the other side 2 units away. Okay? So if I know a point here exists, let's say 5 units away, it's not going to be actually 5 units. I drew this a little off, but let's say it did exist 5 units away. I know for certain that another point exists 5 units away on the other side. So if I had drawn this graph correctly, that would be true. But it was just a sketch, so it doesn't actually perfectly apply. But there we go. Okay, so now what we're going to do is take a look at objective 3, which is finding the vertex of a parabola using the vertex formula. So first what we're going to do is the proof of the vertex formula. So how did it come about? Well, before we start that, my graph is slightly off. So real quick, ignore the numbers. This is supposed to be a general graph. I'll have to change that. Hopefully I've changed that on your version. If not, no, I should have changed that on your version. Okay, so I'm going to go ahead and edit this real quick, and I'll check back in a second. Okay, so here we are with our generic parabola. We don't know what the X intercepts are, and we don't know what any of the points are. And my goal right now is to prove to you how to find the vertex. No matter what parabola you have, there's going to be a way to find the vertex. So how can we do this? Well, one thing I do know is I know the formula for the X intercepts. And you might say, how do I know that? Well, real quick, how do we find X intercepts? Well, we'll set y equal to 0, right? But what's the equation for my graph here? Well, the equation for my graph is going to be the generic y equals ax squared plus bx plus c. And then we could set that equal to 0 because we're making y equal to 0. Now remember, this is the equation for a parabola, right? Well, since this is the equation for a parabola, or quadratic formula, I know the answer to this is x equals negative b plus or minus the square root b squared minus 4ac all over 2a, right? There are 2 answers. So the first one, the positive version, would be x equals negative b plus the square root of b squared minus 4ac over 2a. And then the coordinate point for the other one would be x equals negative b minus the square root of b squared minus 4ac all over 2a. Okay, so those are my 2 x values. And I want to find the vertex point. And remember, that's the midpoint between these two. It's exactly in between both of these 2 values. Well, how do you find the midpoint between 2 values? You add them up and divide by 2. So we're going to go ahead and do that to find the midpoint. And when we find the midpoint, that is our vertex. Okay, so we have my 2 x values. Let's go ahead and find the midpoint, which is going to be equal to our vertex. So let me go ahead and erase this scratch work right here. So my vertex. Midpoint equals the vertex, or the x value of our vertex. So let's take that back. So you know what? A way I label it is v sub x. That's my x value of my vertex. That's going to be the midpoint of my 2 x values. So let's add those up. Negative b minus the square root of b squared minus 4ac all over 2a plus negative b plus the square root of b squared minus 4ac all over 2a. Because remember, I'm taking the x1 value right there, and then the other x value right there. To find the midpoint, add them up, and then divide by 2. This looks hideous, but don't worry, it'll get a little better. Okay, so, well, we have fractions right here. So we can add them because they have the same denominators, right? And when we add them, notice something interesting. We have a negative b and a negative b, so that'll be negative 2b. And then we have a negative b squared minus 4ac and a positive version. So the square roots actually end up canceling each other out. How nifty is that? Then we're left with the over 2a divided by that 2 on the bottom. Well, we can cancel those 2's, and it'll be left with negative b over a divided by 2. That is negative b divided by a divided by 2, which is negative b over 2a. And there we have the formula for our vertex, for the x value of the vertex. How do we find the y value? Well, what you do is whatever x value you find, you're going to go ahead and plug that into your equation to find your y value. So notice here, the formula for the x value always stays the same, regardless of what equation you have. But your y value will change depending on your equation, because you just take your x and plug it into the generic y. Sorry, to the specific y. All right, so our vertex formula. All of that strange work to prove this. F of negative b over 2a. This weird notation here is just saying plug it into your equation. Function notation. Okay, so now you know where the vertex formula comes from, so it's not this strange sort of formula that popped up out of nowhere. So now we're going to find the vertex of this quadratic equation. Y equals negative x squared minus 5x plus 6x. Okay, so how do we find the vertex? First things first, find the x value. And that is given by our formula, negative b over 2a. Well, what are b and a referring to? Those are these values here. That one. Ooh, notice I almost thought that negative 5 was my b value. But it's not. Look at that. My equation was written in the wrong form. My x value is actually on the end, so I'm going to rewrite this real quick because it's tricking me. When I rewrote it, I can actually see that my b value was sneakily placed at the end. So remember, your b value is always by the x power. Okay, so now that I fixed that, let's go ahead and plug this in. So negative b, actually let me do it down here. Negative my b value, which is 6, divided by my 2 times a, which is negative 1. Negative 6 divided by negative 2 is 3. So my vertex x value is 3. To find my vertex y value, how do we do that? Well, I plug it into the equation I'm given. It says that y is whatever x is squared minus 5 plus 6 times whatever x is. So let's go ahead and do that. The opposite of my x value, minus 5 plus 6 times my x value. And what was my x value? Well, my x value was 3. So following the directions for my equation, let's see, we have negative 14 plus 18 equals 4. So v sub y equals 4. All right, my vertex. And this is very important, vertex. Whenever you find your vertex, please label it as vertex. If not, it just looks like it's some random point somewhere on your work. Please, once again, label your vertex, just like you'll label your x intercepts and y intercepts. So vertex is 3, 4. And then we box our answer. Example 3, graph the following parabola f of x equals negative x squared minus 4x minus 7 using the 5-step method. Then state the domain and range. Okay, what is the 5-step method? Well, don't worry, I'll go ahead and explain it to you. So the 5-step method, it is not necessarily required, but it is a good way to remember all the information that I will be looking for on an exam. Okay, so the information that I do for step 5 is the information, once again, that I will be looking for when I grade your work. So easiest way to show all the work that I'm looking for is to just follow the 5-step method. All right, so the 5 steps. Well, the first thing, as most children learn in life, the first step is to list the ABCs. What do I mean? Well, write down the A, B, and C values. A is going to be that negative 1. B is going to be the negative 4. And C is negative 7. Next thing to do, while we're on this step, A and C have important things. A here is a negative. What does that mean? That my parabola opens down. Okay, and I'm going to look that you indicate to me which way your parabola is pointing. So please, please, please make sure to either write this sad looking face here or write opens down. Something like that to indicate to me that you know which way the parabola goes. Once again, that is something I will be looking for. Last thing, what is the C value? Well, that's my y-intercept. Okay, so I can go ahead and just label that right here, 0, -7. And while I'm at it, I'm going to go ahead and plot that point, 0, -7. Okay, so what is the next step? Well, the next step is the vertex. Oops, let me change the color. So, second vertex. Let me just go ahead and, actually, I'll highlight the steps. First step, second step. Once again, how do you find the vertex? Well, you use the vertex formula. So go ahead, you can pause the video and try this out by yourself and check back in with me in a second. So my v sub x value, that is going to be negative b over 2a. And my b value is -4. And my a value is -1. So that'll be 4 over -2, which is -2. So my v value is -2. And my y value, v sub y. How do I find that? Well, we use our equation we're given. Once again, notice, formula for the x value in your vertex never changes. It's always the same. However, the way to find your y value will change depending on your problem. So y is a little iffy. Okay, so we're using the -2 for our x values here. So we're going to place those in our equation wherever we see x. So we have negative squared -4 times that value, -7. And we're using -2 here. So -2, -2. That'll be -4 plus 8 minus 7, which will be 4 minus 7. And 4 minus 7 will be -3. So my v sub y value is -3. And boxing our vertex. Once again, I'm going to go ahead and plot our vertex. What was it? -2, -3. 1, 2, 1, 2, 3. Okay. Now, the next step is step 3, which is to find our X intercepts. That's where we set y equals 0 and solve. Okay, so first, we could go through this and try solving the X intercepts, but I'm going to take a quick look at my graph and ask myself, am I going to have any X intercepts? And you might say, what do you mean? You always have an X intercept. For lines, pretty much all the time, but quadratics, that might be different. Now let's take a look at our quadratic formula, let's take a look at our graph here. My parabola opens which way? It opens down, right? And the vertex is here. So if it opens down, does my graph ever cross the x-axis? Remember, the x-axis is up here. The answer is no, my graph is never going to cross the x-axis. So are we going to have any x-intercepts? No, it's not. There are not going to be any. So our answer here, what would it be? None. And then, remember, you got to give a justification, please. The answer would be the graph does not cross the x-axis. So what would have happened if you tried to solve for the x-intercept? You would have ended up with an imaginary number. And you would have spent a lot of time on your exam worrying about this. And I know this myself because I did this myself when I was a student. I had a math problem very similar to this on an exam, and I spent a good maybe 10 minutes ending up with an imaginary number for my x-intercept and panicking wasting valuable time, and then I finally took a moment to pause and look at my graph and realized there were no x-intercepts. So I had been worrying for a very long time for nothing really. So I'd like to spare you that pain. So make sure to please check your graph before you start trying to solve for your x-intercepts. So once again, we don't have any here. But real quick, what would it look like if we did have x-intercepts? I'll do that in red. Well, maybe you have a vertex here, right? And maybe your parabola opens upwards. So notice, my parabola now passes the x-axis. So that would be an instance, maybe, where we would have x-intercepts. But for our graph, we do not. So that is it. We're done with the third step. Now, in case you're wondering, the graph is actually our fifth step, which is the graph. So the only actual other step that I need to work on now is actually the fourth step. Now, what is important about the fourth step? Well, it has to do with the fact that you're required to have 5 points on your graph. So need 5 points. Okay, so like with a line, you're required to have 3 points. With a parabola, you're required to have 5. At the moment, we're kind of stuck because we only have 2 points. And I can count pretty well up to 5. So I can count and see if you're missing 5 points. So the problem is, how do we find other points? Well, there are 2 ways actually. So real quick, let me write this out. Other points. 2 ways. We can use the table of values. Find an x value, solve for y. There's another method. Try to think back towards the beginning of this video. It's the axis of symmetry. Of symmetry. Okay. So I'll go ahead and do both methods so you can see how they both work. Okay, so first, let's go ahead and use the table of values. I'll pick an x value and solve for a y value. So let's pick x equal to -1. What would be it for y? Well, let's take a look at our equation here. It's negative x squared minus 4x minus 7. So let's write that down. -1 squared minus 4 times -1 minus 7. And that's going to equal -1 plus 4 minus 7. So that'll be -8 plus 4, which is -4. Okay, so we have found one other point, -1, -4. So let's see, -1, -4 right there, -1, -4. And now we can use the axis of symmetry. What a beautiful thing it is, because the table of value takes a lot of work. I don't really like to use it if I can avoid it. So I'm going to go ahead and sketch in my little table of value. Okay, so if you sketch in your table of value, and then you show the indication that you're marking out the other point, I'll be good. You don't need to write out using axis of symmetry or something. Okay? So that other point 1 over would be, let's see, -3, -4. Okay, so how many points do we have? 1, 2, 3, 4 points. Ooh, we need 5. Almost done. Hey, look, I could use the axis of symmetry again. It goes over 2 points, so I know that the other side should be over 2 points. 1, 2. Obviously, my graph isn't that great, so let me fix this. Squeak, squeak, squeak. Okay. So going over 2 points, following the axis of symmetry to better graph my graph, I'll go ahead. Remember, we had over 2 here, so that must mean that the point exists 2 over on this side. Right here, at the point, let's see, 5, 6, negatives, 1, let's see, wait, that was 1, 2, -4, -7. And there we go. So graphing that in, voila. Okay, so my parabola has been graphed. I didn't have any x-intercepts, but I was able to find all 5 points. I labeled all 5 points using either axis of symmetry or my table of values. I was able to find my vertex using Vertex Formula. I indicated that my parabola is opening up or down. I also indicated my y-intercept. I'm good. All right, whew, that took a bit of time. Let's take a look at objective 4, which is solve applications involving quadratic equations. So example 4. A boy threw his toy plane out of the apartment balcony window, which is 100 meters up. The height of the plane can be modeled by the formula. So we're given a formula for the height of the plane, where d of t, so our y values, is the height of the plane from the ground in meters, and t is the time in seconds after the plane was thrown. All right, let's get a visual here. Ooh. So we have a building, right? And somewhere in this building, 100 meters up, there was this young boy who decided to toss his plane out the window. Why? I'm not certain. He just wanted to see it fly, I guess. Okay, so he decides to toss it out the window. More than likely it's some sort of trajectory, and after he throws it in the air, it comes down and falls, right? Just like any object that you throw would happen, right? It has sort of an arc. An arc. That looks a little familiar, doesn't it? Okay, so it has an arc, and then it goes, and then eventually at some point, it'll fall and hit the ground, right? And we have this formula where we can track the height of the object and the time it's at that height. Pretty neat, right? Okay, so this how we find this formula is a little beyond the scope of this class, so we're just learning how to use it. If you go on to the higher math classes, you'll learn how to find these formulas. You'll learn how to make a few of these formulas ourselves. We'll actually do one later, but a lot of times the formulas having to do with gravity and whatnot are usually in the higher level math courses. Okay, so let's see. So the height we track with d of t, so my y values, and the time we track with t. So these are the t values, and these are my d of t values, where t is what I usually say is x, and d of t is what is usually y. So let's take a look at part A. Determine the time. Okay, so determine t at which the plane will be at its maximum height. Ooh, hopefully that word caught your attention, maximum. Okay, so remember, I warned you with word problems, when maximum or minimum pop up, that is referring to the vertex. And what do you know? We do have a vertex here. This is a parabola, parabolic-like shape. How do I know? Well, that's a quadratic equation. Once again, highest value is a square. So we have our maximum, which means I want to find my vertex. And I want to know the time, which is my x values. So I just want my v sub x value. Well, that'll be pretty easy. T, so the maximum time, let me write this out. Max time is going to be equal to the v sub t in this case, which will be negative b over 2 times a, and my b value is 10. So negative 10 over 2 times my a value, which is negative 4.9. And what does that come out to be? 4.9 times 2 is negative 9.8, negative 10. That comes out to approximately 1.02. Okay, so what time at which will the plane be at its maximum height? Well, we could actually round this up to, and we weren't given what to round it to. So on the exam, if you're given that, you would make sure to round that off. If not, you either round it out to the 10th or the 100th place. So that is about 1 second. So my sentence is the plane will reach maximum height at 1 second. So that was my v sub x value. Next, we're asked to determine the maximum height. Ooh, so now we're talking about the height. And the height, or my y values, sorry. So now I want the v sub y value, my maximum height. So how do we find that? Well, we'll just use our v sub x and plug it in. So v sub y, or in this case, well, yeah, we'll use v sub y. V sub y is going to equal negative 4.9 times 1 squared plus 10 times 1 plus 100. Where'd the 1 come from? Remember, we solved for it right there, and we're plugging it into our equation there. So v sub y equals negative 4.9 plus 10 plus 100, which is going to equal 105.1, which will round off to about 105. Once again, we weren't given directions on how to round. Okay, so what is this saying? My maximum height, or the maximum height is 105 meters. Okay, so he actually checked it pretty high. So he was at 100 meters and he threw it up about 5 more meters. And then it started to fall. Okay, yeah, it's pretty believable. Okay, now let's take a look at part C. Determine the time. Okay, so determine t at which the stone will hit the ground. I'm not actually given anything here. I'm not given the time and I'm not given why. Let's take a look at our graph here. When the rock hits the ground, we don't know what time it is, but do we know the height of the object? Not the rock, I'm sorry. That should say the plane. I have to edit that on your problem. Hopefully I edited that as well. Okay, so the plane will hit the ground. We don't know when, but we do know the height. And the height is 0 meters. Because when you're on the ground, face down, how high off the ground are you? You're not off the ground at all. You're on the ground, right? There is no height. 0. Okay, so the plane will hit the ground. We don't know when, but we know the height will be 0. So, d of t, so we want the time when d of t is 0, because the height off the ground is, 0. So let's solve for that. So we have d of t, our equation, equals negative 49.t squared, 4.9t squared, plus 10t plus 100. Let me just check and make sure my equation's right. Yeah, looks good. Okay, so plugging in 0 for y. Oh, this looks like we're going to have to work with a quadratic equation here. Negative 4.9t squared plus 10t plus 100. Okay, this looks like a quadratic equation, and I don't know how to factor a decimal. So my only plan, or my only option, would be the quadratic formula. So t is going to equal the opposite of b, which is 10, plus or minus the square root of b squared, minus 4 times a times c, all over, 2 times a. And let's see, so t is going to equal negative 10 plus or minus the square root of 100 plus 1960 divided by negative 9.8. And then let's see, what would that be? So negative 10 plus or minus the square root of 260. Sorry, that's supposed to be 2060, which is not a perfect square, so that's not going to come out nicely either. So plugging this all into our calculator, what we get, t is going to be approximately, well, actually, I'm going to go ahead and break my t value into 2 options. Because remember, there's the positive and the negative option. And more than likely, I'm not going to end up with a negative option. And we'll check into that in a second. So you have 2 options. T is negative 10 plus the square root of 206 divided by negative 9.8, or actually it's and t equals negative 10 plus the square root of 206 divided by negative 9.8. Okay, so let's go ahead and plug these into the calculator and figure out what they are. Okay, so this will come out to some sort of a repeating decimal of about negative 0.44 repeating. And then let's take a look at the other one. Oh, I just noticed they're both plus signs. Let me go ahead and fix this. That will be our negative. Okay, so plugging in that negative there and calculating that out, we'll get t is approximately 2.48. Okay, so rounding that up, t is about 2.5. Okay, what does this mean? Well, we have two options. Our plane hits the ground at either negative 0.44 seconds or 2.5 seconds. Does it make sense for a rock to hit the ground at negative 0.44 seconds? No. Can't have negative time. Okay, so notice I crossed my answer out and gave the justification. And then I'll go ahead and box this answer. That one works, but we have to write a sentence. So what is my answer? So the plane will hit the ground at 2.5 seconds, period. Okay, so let's take a look at example 5, which I believe is the last one for this video. So example 5. A farmer has 200 feet of fencing and wants to build 3 adjacent rectangular corrals as seen in the provided diagram. Okay, so we can see that right here. So we have, oops, wrong pen. So we have the 3 little corrals, and we don't actually know any of their dimensions. It's not mentioned. But we know he has 200 feet of fencing to build these. Okay, and we're talking about, remember here, the perimeter, right? When you build a fence, you're talking about perimeter. So, A, determine the dimensions that should be used to maximize the area. Ooh, the word maximize. Okay, maximize, we're talking about vertex. But the vertex of what? We don't have an equation. So that's what we have to do first. So we know maximize is talking about vertex. First, let's see, how are we going to figure this out? So we want the area. So let's see, we want the area, which is going to equal base times the height for a rectangle, right? So the base would be whatever y is, and the height would be whatever x is. Okay. Well, so A is going to equal y times x. Ooh, but that's an equation in x and y, and I haven't learned how to deal with 2 variable equations. Okay, so I have to think of another way to fill this out. I have x, which I'm used to, but I don't know how to deal with y. Let's go ahead and bring in the 200 for our equation. Well, what we know is that the perimeter, right? So the perimeter of this is 200. Let me rewrite that. So the perimeter is 200. And the perimeter of my equation here is going to be the 1, 2, 3, 4 x values, so 4 x's. Add those sides up with the 1, 2 y values. Because remember, the same length on the top as it is on the bottom here. Plus 2y. Okay, Hey, can I solve for y here? If I can solve for y here, then I know how to take away the y here and replace it with something in terms of x. So let's do that. So solving for y, let me minus the 2y from both sides. Then I have 4x minus 200. Divide by negative 2 from both sides. We'll get y equals 4x minus 200 divided by negative 2. Aha! So now we found out what y is. I'll go ahead and replace my y in this equation with that value. So you might be wondering, why are we doing this? Well, remember, we don't know how to work with a variable in 2 variables yet. So we need to rewrite this in terms of just x, which we know how to work with. Okay, so when I do that, a is going to equal, let's see. Well, we could simplify this here, taking away the 4. we could get, sorry, taking away the 2, we get negative 2x plus 100 times the x. So a is going to equal negative 2x squared plus 100x. Ooh, okay, so now we have a quadratic equation, which I know how to find maximum and minimums for. So I'm going to go ahead and move this real quick. Okay, so I'll move that right there. I'm going to go ahead and relabel some of this. All right, so let's see. This was finding y. So up on the right, this was finding y. And this is quadratic equation. For area. So now we want to find the maximum. So finding maximum numbers. So to find the maximum numbers, we need v sub x, and v sub x is going to be negative b over 2 times a. My b value is 100, and my a value is negative 2. So negative 100 over 2 times negative 2. It'll be negative 100 divided by negative 4, which is, 25. Okay, so now you might wonder, how do we find our y value? Because remember, we're trying to find the dimensions, so we want our x and y value. So we found that x is 25. The question is, should I plug the 25 into this value or this value? Well, let's think about what these are answering. This one will tell me my y value, whereas this one will tell me the area for my problem. So we just want to find our y value. So we're going to use this equation here. So use y equals 4x minus 200 divided by negative 2, which will be, so 25 times 4 minus 200 divided by negative 2. So y is going to equal 100 minus 200 divided by negative 2, which will come out to negative 100 divided by negative 2, bringing that over here. So y is going to equal 50. Okay, so here we have our maximum values. So the dimensions are, or the maximum dimensions are 25. Now we're talking about feet here. What are we talking about? Yep, feet, 25 feet by 50 feet. Okay. Now, let's find the area of each individual corral. Ooh, okay, what does that mean? Well, let's see. If I redrew this picture here, I know that each corral, we have 25, 25, 25, 25, and then 50 for the whole thing, and 50 for the whole thing. So the area of each individual corral. So remember, we mentioned that they're supposed to be the same dimensions, which means each area will be the same as this one. And how do we find the area? Well, the area of one of these is going to be the base times the height. And the base is, a third of 50. So what is a third of 50? Well, I don't know. So I'll just do 50 divided by 3 times the height, which is 25. So then my area is going to be 50 times 25. It's 50 times 25, 1,250 divided by 3. The area, it does not come out pretty. So approximately 417 feet. Once again, you'll be told how to round depending on the problem. So the maximum, or the area of each corral is about 417 square feet. Note when you're talking about area, you start talking about square feet. So you could write square feet or you could write feet squared, up to you. As long as you indicate that it's the squaring, because we're talking about the area. All right, and that is it for 3.1. Please email me if you have any questions.